webinar. I'm your host today, Lu Yang. I can go by Lucas. Nice meeting you all. Before we start, there are a few updates from DFWIT Association that we'd like to share. So first, let's welcome Chun, the COO of DFWIT. Hey Chun, you're up. You're muted. Yeah.
Yep. Can you hear me okay? I was changing the microphone earlier.
Yep.
Okay, great. Let me see your little beautiful faces. Where are you guys? Okay. So good morning, everyone, and welcome. Thank you for joining us today for this tech seminar of DFWIT. So before we start, I'd like to take a brief moment introducing what DFWIT Association is and just share a little bit of who we are. So DFWIT is founded by a group of technical professionals who wanted to have a more connected, stronger community local here in Texas. But what started as a small network of people, sharing ideas, supporting each other, slowly, gradually grown into this broader platform now that's for, supporting professional growth, encouraging innovation, and help building this stronger and more collaborative community here in Texas. So today, DFWIT runs a variety of programs. So we have this tech seminars, we have workshops, we have a forum where you can share opportunities and ideas, and we also have mentorship opportunities, and we have the AI computation initiative, which is we try to for people to share startup ideas, encouraging innovations and practical AI innovations, not just regular innovations, and also entrepreneurial collaborations, right? So today's seminar is also a great example of that vision in action. We are very excited to host this session about AI, agentic framework, workflow, AI-driven development. These topics are evolving incredibly fast, and they're reshaping the idea of how people are building software, developing business and products. So our featured speaker today is Karl Weinmeister from Google Cloud. Later, Lucas will have a more deep introduction to him and the topic and sessions. But before we move into that session, I also want to briefly recognize the people and the organizations that help make these initiatives possible. So on the screen, you'll see our sponsors and some of our volunteers. We are a volunteer-driven organization. So a lot of things we do is only possible because of the people who contribute their time and energy into this organization. They have a lot of passion, right? So thank them for their effort. And on the screen, you also see a QR code to join our inner circle. That's our forum where our members are sharing ideas and stay connected beyond events like this, and collaborate more. So scan that and join our forum if you want to be involved in the community. And with that, thank you again for being here this morning, and I'll hand it over to Lucas. You're on mute.
Sorry about that. I'm talking to myself. Thank you, Chun. Next, as the chair of 2026 AI and Startup Competition, I'd like to introduce the competition in a bit detail. Okay. So DFWIT started hosting its annual AI competition from 2027. Now we are working on our fourth year cohort. So you must be wondering what it is and why I should join, right? Well, what is it? I believe you've seen a lot of hackathons, maybe too many, but we are not one of them, right? Especially this year, we emphasize the usability and the marketability of your idea more than ever before. So we'll select those ideas with the greatest potential to develop into a real company, a real business, or a nonprofit organization, right? So the winners will also get their chances to participate in our Venture Ready program, which is the incubation program sponsored by DFWIT. So we are not a traditional hackathon. We are I call it dream launcher, actually your dream launcher. Okay. I'm not trying to talk you into anything. Instead, I just wanted to review one obvious thing that is currently happening. So AI has lowered the technology barrier for everyone, including you and me, right? Even if you don't have an engineer background like me, AI has enabled a lot of capabilities for us. As long as we have the idea, we have the motivation, and most importantly, the actions. So the competition is where all these will start. Okay. In fact, there are a few projects in the past cohorts have gone a long way. For example, this Dream College project, it stemmed from our 2024 competition and has made great achievements in the past couple years. If you paid attention to the screen before we start today, it has become a sponsor of the competition and started giving back to our community. So we believe there will be more and more projects like Dream College and more successful stories coming out of the competition. So next could be yours, right? If you need some inspirations on what to create, on the screen there are some examples, but I would suggest you think about it uh, strategically. Like for example, everyone knows right now in the AI industry we have 5 layers, right? Power and infrastructure, chips, models, platforms, and applications. So you can find a lot of gaps and opportunities by scanning these layers, layer by layer. So besides, in my opinion, there is another layer, which is the outer space of the sphere. So the development of AI industry will induce more demands to other industries, or even create new industries within this outer space. So this is much bigger. So just look around you, right? Opportunities are everywhere. You just need your eyes to look for it. And so the competition will just be the spark to inspire you to start your journey. Again, all these on the screen are suggestions, not boundaries. In fact, we don't set any boundaries for this competition as long as it's related to AI, is legal, and is ethical. Cool. So I believe you still have a lot of questions like timeline, judging criteria, etc., right? Scan this QR code on screen, visit our website, you will find most of your answers. You can also type in our URL, ai.dfwit.org. Again, it's ai.dfwit.org. By the way, today is the last day for enrollment. Don't miss it. You still have about 14 hours. All right, check it out. Okay, without further ado, I'd like to introduce our speaker for today's seminar, Karl Weinmeister. Karl holds a bachelor's degree in computer science and economics from Duke University and MS in data science from UT Austin, and an MBA from the Texas McCombs School of Business. He is a published author, having co-authored books like Swift in the Cloud and contribute to uh, Proverb, the probabilistic sorry for my, I couldn't even pronounce it. Cruciverbalist. Okay, which is a foundational AI paper on solving crossword puzzles via probabilistic AI models. Additionally, Karl holds 4 patents in data science and IoT devices. Based in Austin, Texas, Karl is passionate about getting hands-on with the latest tech and vibe coding new app interfaces. He is an executive sponsor for his organization's Health and Wellness Committee. In addition, he's also very generous about his time and efforts to support the community. That's why he's here today. So before I hand over to Karl, I'd like to remind you, everyone, to remain muted during the lecture. If you have any questions, feel free to type it in the chat window if you worry about forgetting it. After Karl's lecture, we'll leave enough time for communication. Okay, cool. Karl, the stage is now yours.
Thank you, Lou. Thank you, everyone. It's great to be here. And really appreciate all of you spending your time on the weekend. It shows that you're really interested in learning and growing, and hope this is a helpful session for you. So I'm going to talk about 3 topics today, all about AI, but kind of related. So the first is building with agents, the tools that are now used to develop agentic workflows. So MCP servers, skills, spec-driven development. We're going to talk about the latest trends there. Then we'll move on to developing your own agents and a framework. And this is not, a vendor pitch or anything. I'm using some of the examples of technologies and frameworks I know best with Google technologies. But really, I hope that through this, you learn a lot and you learn how to apply it. Finally, we'll move on to managing. So, when you think about the different steps of the process, everybody's vibe coding these days, building solutions, and then you're also, needing to build real agents. But beyond the building part, you need to deploy them. You need to think about all those, day 2, day 3 type of issues. So we'll cover all that today. So let's now dive into. I've got some slides and I've got some demos as we go, just to kind of make it, concrete. So here's the topic: from building to managing in the enterprise, agents in 2026. So let's start with a little piece that is from a blog post you'll see here linked, or it's called "The Software Development Lifecycle is Dead." Very strong words there, but really this, I think, highlights some of the trends and changing ways of approaching software development that are useful for all of us. So first, there's the traditional SDLC, or software development lifecycle, if you're familiar with that, starting with requirements, design, coding, test, deploy, and so on and so forth. In many cases, you see this change into from waterfall to agile, right, where there's a loop, kind of like what you see there on the right. Instead of one big bang, you see cycles. The approach with AI agents really collapses that even further, where you are going to need to manage this in smaller and smaller, tighter loops, and we'll walk through that here. So some of the changes that you see are on the requirement side. Instead of all the upfront planning, our favorite Jira tickets and all of that, we're learning as we go. We're having the agent discover its environment and update the requirements, and you're its partner, kind of guiding it along the way as you have new information. Secondly, from a testing perspective, this definitely shouldn't be a next, like a separate step. It's simultaneously. Testing is more important than ever, because as your agent is moving faster and building things quicker, you need those guardrails in place so that the business rules are enforced and the code isn't trampled on. The tests need to be built as you go. And your software development agent can help you with that, of course. You just want to make sure that you're really putting testing in along the way. Code review is interesting because we're seeing in many open source projects, including some that our team manages with Google Cloud, that we have so many contributions coming in. People are so excited. They're building things or responding with pull requests, with issues that they fix. But what happens is further down the line, it's a process. It's not just the building part, right? So you need to review all those changes. And that's where there's a human bottleneck right now, where there's just on many open source projects, not enough people to maintain them. So we need to do things differently. And so we're also looking as an industry at how can we have automated tooling to help assist that process and reduce that bottleneck, make that part faster. And I could say myself, like often the code reviews are much better when they come from an AI agent that might be connecting the dots across, documentation, across a very large code request, kind of seeing inconsistencies that a human reviewer might not see. And the final thing I want to mention is deployment. So there continue to be the human in the loop process, especially around sensitive, mission critical applications. And as we increase the velocity, some of the deployment practices like feature flags and rollbacks are important. So feature flags are a concept of you have Booleans that enable flags of features to be turned on or off. And if you quickly need to turn something off, it's just a matter of changing an environment variable. You don't need to go through the whole deployment process. So you've got safeguards built in, you can adapt quickly. And when you take a step back at all this, it's not really anything new. It's really the evolution of the best practices of modern SDLC, just kind of accelerate and take it to the next level. So let's move on to the next slide here. Observability is one of those best practices that also is more important than ever. It's one of those things that's like, eating your vegetables. Yeah, we need to add good logging and tracing to our applications, but really it's critical because we want to have signals available to the agent around telemetry, logs, all of this, so it can make decisions and remediate issues in real time. So the previous world of observability was kind of rear facing, where you're looking at dashboards, you're kind of looking in the past at what's going on. Instead, you want to surface as much signal and then have an agentic solution reviewing and adapting as you go. So building observability up. So to kind of bring this all to a close here from a development process, there's two takeaways from this. One is, as a developer, you're now really thinking about your job as an architect of the solution, not only understanding the code, but also how it's built, what is being built, and you're doing that through something called the context. It's the information that you provide to the agent, the requirements, the best practices from your enterprise, and other piece of information. And you want to give the agent enough information, not too much where it's going to get distracted by information overload. You want to keep it focused. You also don't want to keep your instructions too vague. You want to make sure you're very clear on what you want. And that's what the context engineering is all about. And finally, the observability safety net that we described to allow for that quick closed loop feedback and fixes. Okay, so now let's look at some technology on how we can implement that today. So many of you, I'm sure, have heard of Claude Code. This is just one example of a software development agent, and it's a CLI or command line interface, and it allows you to code or answer questions of all different kinds, and it has context around your file system, and it has various extensions that we'll talk about soon here to make it even more powerful. On Google Cloud, it's actually very easy to integrate Claude Code with Google Cloud. So you can see here there's a built-in command into Claude Code, set up Vertex. And when you do that, it asks you for your form of authentication. Probably just let's say for me, I had this already set up, just hit enter on application default credentials. And then it asked me about the models that I wanted to use. And those are on what's called the model garden on Google Cloud. We've got not only the Gemini models, but we've got a wide variety of partner and open models. So I just needed to select which models, and then I was good to go. That's all it takes. Now let's talk about some of the add-ons to your agent. So you just saw it, an agent out of the box. You install it, you're ready to go. Now, how can you improve on that and customize it for what you need? So here we're seeing an example of skills. So let's look at the old way for a second. Prompts and prompt engineering. Remember, that was even going to be the new job about a year ago. We talked about the prompt engineer. And as time has gone on, that works, and many people still, including myself, use prompts. That's how we interact with models, but there are better ways. So here we have an example where, let's say it's a financial application and you're asking it to analyze the ledger and flag discrepancies and things like that. So it's some accounting software. And you can see here that there's a little bit of ambiguity, right? If you ask the same question 3 different times, you'll probably get 3 slightly different answers to it. With skills, think of that as a packaging of a prompt that allows you to package up that prompt for the enterprise. And so everybody can use the same one. On top of that, you can put standard definitions. You can even put like validation code within that skill. So it's just a packaged set of information. So it's like taking your agent to school. It's giving it specialized knowledge to be more repeatable in how it does things. And it's very lightweight. You see, it's just a few files. And how it works is with progressive disclosure. So going back to this idea of your context window and finding that sweet spot of enough information to navigate things, but not overloading it. How this works is that the agents that you load, or rather the skills that you load into your agent, provide a metadata so that your agents, when it's solving a problem, it says, oh, the user is asking me about a finance question, and I happen to have a skill that solves that. Let me find out more. And so it will then look up and activate that skill. And then once it's activated, you see level 2 and level 3 being available. So it adds that to the context. So level 2 would be, for example, providing concrete instructions of what to do, loading files, running scripts. And then even deeper, you have the resources that you package with your skills. So maybe some definitions or options, things like that. So again, it's progressive disclosure. So you can have a bunch of skills loaded and you don't have to worry about too many skills in your agent. And skills are really becoming the new thing. They're everywhere. You can see, for example, throughout Google Cloud and Google, we're using skills for a ton of different things. You can see the official launch post that we just released last month or so at our Google Cloud Next conference about our official skills repository. So you can find trusted skills that you can install in your environment. On the right side, you see a tool that's from Vercel. You can just run with NPX skills. It allows you to add skills, find from a catalog. I'll demo that in just a second. And spec-driven development is this idea of not interacting with the code, abstracting the code away by dealing with specs or specifications. So you build out your requirements, probably with help from your agent, and then you implement it. And now let's say you find a bug or something you want to change. You don't go into the code, you go back to your specifications, and through that, then you instruct the agent to make the changes. And then you've got an always documented set of requirements that way. Now, there's different opinions on this approach. You're kind of updating your requirements with many layers of AI enhanced instructions. It might start to drift a little bit from what you're looking for. I personally sometimes will start this way and I'll be working in the code, and then eventually I might sync it back up and say, hey, my requirements have gotten a little out of sync. You have to be careful if you do it that way. But yeah, it's a helpful way of doing software development. There's a couple of frameworks out there. One's called Superpowers, if you look that up. Google has one called Conductor. Microsoft has spec-driven development framework, and there's many others that are popular, so worth checking out. And the next thing to think about is back to the idea of the whole SDLC. You can think about it as two different loops of development. Inner loop is you're moving fast on your laptop. You're iterating, you're building code, and you're working well by yourself. But that's not the reality on larger projects. You're working with a team, you're working with standards. That's where the outer loop comes in, where you need to integrate that into infrastructure. And with AI tooling, some of the things you want to think about, number one, with security, having secret scanning. So there have been incidents, for instance, where people are moving super quick and they push a key, an API key to like public GitHub or something like that. So you'll want to have some safeguards in place that scan for those secrets. Of course, you need to use your gitignore file and different safeguards like that. But using some tooling is helpful for that. Secondly, designing a continuous integration pipeline so that every time that you make changes, you're linting the code, testing the code, and so on. And ideally, all of your infrastructure is code. And again, that can be designed with AI. Cool. So that's the build part of the presentation. Let's now switch to a quick demo. And I'll switch tabs here for that. So here I am in an environment called, basically this is a VS Code, Visual Studio Code equivalent. I'm just showing an app that this isn't going to be a big demo or anything. This is just showing how you'd configure Claude Code. So my demo agent that I have here is displayed. I can run Claude, and it's well integrated into my environment. It can actually operate here in the terminal and be kind of working back and forth with your IDE. And I could say update my project dependencies or something like that, and it will go and work for me. Looking at how I could do some updates, something that's kind of manual. And I won't go through that, but just wanted to give you a quick picture of how Claude works. Let's now take a look at skills, if you remember that in the presentation. So NPX skills is the tool, and we need to install it. And you can see the various commands here. So if I am wanting to build with agents, for instance, I need a little bit of help. Let's say I'm using one of Google's frameworks here, NPX skills find ADK, the Agent Development Kit. It would search here and it would find the skills that are helpful for me and a URL to the catalog. So I could click on one of these and I'll share that in another window. And you can see this is in a catalog of, I'll back up 1 second here. This is the catalog of skills from all different kinds of vendors and locations. I think somebody needs to go on mute, by the way. Thought I heard a little background noise. So let's go back to the skill itself. Here's where you would find information on how many stars, README, and all of that. So what's great about this is that you can do it all from the command line. And that's the real benefit with the CLI, is moving really quickly, not having to kind of navigate a bunch of websites and adding those skills. And then once I find the right skill I want, I can just say NPX skills add, and then I'd add that URL, and then it would be plugged into my environment. So I could even do one of these right now just to kind of show that off. And so it's pulling it down, and notice that it supports all kinds of agents. And you see from anti-gravity to Gemini CLI, OpenCode, Codex, etc. Some of the agents use a slightly different folder structure. And so that's where instead of this sort of common location for storing skills, where any agent supporting that, it would just work. Some of the other agents that use a custom folder, you'd need to select that. And then it's going to go ahead and install it. Cool. So that's the demo on agent development. Let's keep moving through to the next stage, which is building with agents. And so first, let's look at models. When you look at the whole stack, models are, the analogy is always the brain. Agents are the automation construct that uses a model to drive it. And then the platform is what it runs on, and then it all needs to be governed. From a model standpoint, just showing a few of the Gemini model variants, what you see here is that all of them are great for different purposes. And this, I'm not going to go through all the details on this slide. I think the takeaways would be, on the left, you have Pro, which is the highest quality, most powerful, most thinking. However, it costs more and the latency is higher. So, for certain problems, it's great. Flash is in the middle. This is, for many folks, the sweet spot where it's nearly the same results on benchmarks as Pro, but is faster and less expensive. And it's a great model for those capabilities. And then Flashlight is for the really quick, least expensive model, and that also has its place in many solutions. Let's say you're doing routing to other models, classification. Use the smallest model that does the job for you. And you see too that the general features, like the number of tokens that can be stored in the context, the types of multimodal inputs, are consistent across the model. So you can easily adjust to pick the right one. And I talked about the model garden. This is where you can view the set of models available to you. And I'll just kind of show that real quick here. So here I'm in my project, and you can see a listing of Google models, but also, partner models. So, you see Claude and you see Llama, they're all available, and you can go into one of these and try it out. There's notebooks and all the documentation that you need here. Okay, so this really gives you the kind of backbone of your agent. So whatever model you want to use, you can use either the first party or partner or open models. And when you're choosing a model, there's a few characteristics. One is the capabilities. Is it tuned for your model? A lot of models are, let's say, in the same class. They're the high-end, powerful models. They're not all interchangeable. Some might be better at coding, some are better at general answers, some are better at certain kinds of coding than others. A lot of this comes down to almost that feel, like as you're using models, what seems best for your tasks. Of course, you want to go beyond what feels better and do something called evaluation to try out different models and see for yourself and use data. But the point is that it's highly problem dependent, that if a problem is well suited for a particular model, you'll want to use that versus just picking maybe what you know. And from a performance perspective, we talked about those trade-offs of you can have higher accuracy. Generally, that comes with more latency, and it comes with more cost. So you just have to pick that for yourself. Finally, with cost, you have a build versus buy decision with models. You can pick an off-the-shelf model API, so you have no hosting whatsoever, no infrastructure, and you can just point right to a model and you're all set. Or you can choose to host the model, and let's say on Google Cloud, the Kubernetes engine, where you can take a model, say like DeepSeek, and you have instructions to deploy it and host it yourself. So this could be where maybe you have a custom model or a model that you fine-tune to your particular needs. You might go that route instead of using an API. Cool. So now let's move on to agents. We've talked about the models themselves. Now, how do we use the models to solve problems through agents? So let's now look at the sort of alphabet soup here of different technologies. Some of you may be familiar with these. I'll just make this pretty quick as we go into some examples of A to A, ADK, and MCP. So first, ADK, or Agent Development Kit, is Google's agent framework. And in ADK, it's just one of many choices. There are a number of other frameworks out there. Many of them have similar constructs that you see here. So if you learn ADK, I think you'll be well suited for all the other frameworks as well. What is in an agent framework like this? So let's kind of go left to right and take a look at this. So we've got the model, of course, that we just talked about, a number of models that can help the agent make decisions. Within the model, in the middle here, within the agent, you have the name of it. You select which model that you want to use for it. The instruction, and this is key. What is the purpose of the agent? What is it supposed to do? And then the tools, or what are some of the integrations and other capabilities that are outside of the agent that it can call to perform functions, whether that's some functions that are built in on Google Cloud that are very helpful, like things like Google Search, or some built-in RAG capability, or whatever tools that you want to build and share across your enterprise or that are available open source. You can use those tools. You can see the input and output will be not just text, right? So this could be audio, video. We're seeing increasingly more use case for multimodal. And then on the bottom right, you see sub-agents. So this is where you may want to deconstruct an agent so that it's not like this Uber agent trying to solve every problem. You can delegate some of the work to other agents. And that's something we'll show in a second here in an example. Here's how the code works. Just a little quick snippet of it. You import the library, and this is the definition of the agent, its name, the model it's using, a description, and then a couple of the really important parts, the instruction and the tool. Notice that this instruction says you're an agent that answers all the questions. That's usually not a good instruction, and that you want to be very clear with your agent what to answer and what not to answer. So if you think about, say, a customer service agent on your website, you'd want it to be scoped very clearly that you can answer questions about these topics, but when it comes to some things that are out of scope for customer service, say, sorry, I can't help you with that, direct them somewhere else. And then the tools, you see there, it's a list. So you would have, in addition to Google Search, you could add on other tools that you make available to agent. And that's it. That's basically the code right there. So MCP, or Model Context Protocol, is a protocol for communicating with tools. And if we look at our agent here on the left, you can see that it might want to call out to this catalog of tools on the right side. So the MCP server is like a catalog, an index. It houses the various tools that you want to make available to it. So your agent is a client of that server, and it can call out to the server and list the tools. What does it have available? And then if the tools are useful to the agent, this is where the brain and the model comes in. It's doing its thing. It's answering the questions that you give it. And then it connects the dots and it says, oh, they asked me about something that would be very helpful for this tool to help with. And then it decides to call the tool. That's where, the way you've constructed the agent, the model matters, because you want to make sure that it's calling tools in the right situations. So that's the connection there. And then that MCP server, you can see, has a variety of different, kind of fake tools that we have there, but it could be, calling out to databases, email, a number of things that are deterministic. Think of it almost like system integration type of functions. So that's MCP. A to A is not for agents to talk to tools, but for agents to talk to other agents. And, the way I look at this is that it's a good thing to have you're maybe not going to do it on day one, but as you are working with more agents and you're working within a larger company, this is essential. So the couple of situations I always bring up is one, it gives you choice so that if, say, one team uses ADK from Google and another team uses, Crew AI or another framework, that's great. You don't necessarily have to all use the exact same agent framework. A2A abstracts that so that those agents can talk to each other without being in the same framework. Also, from a language perspective, maybe you have a team that's working in Java, another team in Python. You solve those interoperability challenges by just working with A2A. With A2A, each agent defines a card that specifies what it can do, its skills, and authentication, and then other agents can discover and call it. And that's basically what I laid out here, that A2A server holds the agents and provides the cards or the descriptions of those agents. And then your calling agent can look up on the A2A server and get information and work with that other agent as it needs to. And to close out this section with ADK, it's can be built in with the new agent CLI framework, where you don't necessarily need to know all the details of the ADK code. You can use the CLI, and it will allow you to connect to ADK and build that in your framework and scaffold it out. So it's a great way to get started with ADK, is just try out the CLI to build out your agent for you. Cool. So I'm, got, from a time perspective, I don't have a lot of time. I've got even more material to show you, but I want to show you just a quick demo of different agent patterns. So this is a website. I can provide the link here. It's available on GitHub, where we have some agent patterns. I'll give an example of a pattern here, the orchestrator. And this is an example of a pattern where, let's see, it's running a little slow here. Let's try that. Yeah, so behind the scenes here, I'm using Cloud Run, and Cloud Run has a neat scale to zero feature. So when you're not using your app, it kind of, it's not charging you anything. But that also means there can be a little bit of what's called a cold start when you haven't touched it for a little bit. So cool. So now we've loaded it. Here you see the orchestrator pattern. And the way the orchestrator pattern works is that you ask it something, and then it creates a plan, and it divides out the work between multiple sub-agents, and then has another agent at the end that synthesizes and kind of brings that all together into a final response. Let's take a quick look at the code. This is what we saw before, where you define an agent with the name, a model, and instructions. And, there's a couple agents here, right? Because each doing different things. So that's, not a lot of code, but, and this is a fairly sophisticated pattern. So let's now apply this. Let's say, we're, working with, you're part of the, DFWIT community. You're planning out this seminar, plan out an AI hackathon. What would the steps be? How can we kind of break apart this problem into sub-agents and solve it? So it'll take a moment here. And what do you see here? The agent decided it needed 4 different sub-agents. And this was on the fly. Every type of problem, it will break up in different ways. So it needed operations, architect, marketing, event coordinator as 4 different sub-agents trying to solve this, defining the hackathon themes and things like that. And so each of these agents is going to independently be providing information. And then you see at the very end the plan, right, where the agent comes together with this whole plan. So that's just one of the patterns. There's lots of them, shown here, where sometimes you synthesize, as you see here. Sometimes, and I'll show that in the next demo. Hopefully, I think I have time here. Is where you pick the best one. You kind of vote, and you say the agents aren't working together; they're working separately. And then we just pick the best answer. Here's an example where you combine them together. Cool. So that's that demo. And now let's move on to the final part of the presentation, which is about managing the agents after you've deployed them. Some of the problems I hear from customers is that they're making a lot of progress with agents. So when I was at Google Cloud Next, I heard from customers that had dozens or hundreds of agents in their enterprise, which is great. That also means you need to organize more than ever before, understanding how these agents are used. Are they following common policies? Those kinds of things. Secondly, one of the challenges with agents, as we know with large language models and AI in general, is that they're non-deterministic. So there's new techniques and solving things a little bit differently than traditional software. And the framework on Google Cloud for managing this is, with the agent platform, and it consists a lot of the components we've talked about so far. We've got our front end that you might have for your application, let's say a web app, or it could even be all automated through API trigger. You may have an agent gateway sitting in the middle, and this could filter the responses, for questions that, you wouldn't want people asking the agent. On the right side, you see the agent gateway coming out. So you can have model armor on looking at the model responses as well, looking for, PII and these kind of things, and just making sure that that's governed properly. You also now have agent identity. So the agent itself can have its own agent, or it can delegate on behalf of the user. There's a security framework around that. And then the various agents, tools, models, APIs stored in a registry, so they're available throughout the enterprise. And the sort of mental model here is shifting down. What this is showing here is, if you look at the left side, there's just a lot of stuff as a developer you need to remember these days. Security, DevOps, and the traditional model has been shift left, where you say, hey, don't think about security at the very end. Build it in. You see where the green part is. Build it in from the beginning. And now, that again, that's hard to do. That's just a lot of things to remember. Shift down is this idea that you push it into the platform itself, so that your cloud provider can help with just doing a lot of this stuff automatically. So it's not brought to the beginning of the human process. Rather, it's just done the right way as you go and integrated deeply into the platform. So let's do a quick demo here. I'll show the another agent. This was part of the design patterns as well, but I have it as a standalone app. So here is this voting pattern. This is what I talked about, not a pattern where we include all the agents together. We have a judge agent that picks the best one of several. So let's take a look at this one here. So I've deployed a web app for this. Let's go ahead and try out this agent, and I'll say, I'll kind of use the example here, a smart coffee mug with Bluetooth, whatever that would look like. And this app is just kind of a fun little idea of advertising copy. So we take the product idea we have here, and then we say, do we take a humorous angle, professional, urgent selling angle, and let's come up with some ad copy from those perspectives, and then have the judge pick the best one. And it might take a little bit here. And so again, this is the voting, or it's called best of in pattern, and it picks the best one. It should come up here in a moment. I'll give it a little. Oh, there we go. Perfect. So let me zoom in a little bit. Okay, so you can see each of the different approaches and what the judge decide humorous. And and you see the reasoning for it. So this part, this is where this will lead into memories and some of the platform capabilities you can add to your agent. So notice it said, given your preference for wit over corporate tones, this creates a memorable brand personality. That's because I'm collecting memories as we go. So every time I say, do I agree with the judge? Sure. And I'm storing a memory there so that next time this agent runs, it's not just starting cold. It kind of knows the preferences of the user. So now let's take a look at the agent platform to see how that works. So here we're in the Google Cloud Console, and I'm here within the agents section. I'm not going to show all the different tabs here, but I just want to show a couple of the ones that are relevant to what you just saw. So first, the deployments. So let me close that. So here we have under voting agent, the agent that I've deployed. And you can see with this agent, the metrics are going to probably take a little bit of time to show up, but yeah, we've run this a couple times here. We have a overview of the agent, the latency, the number of times it's been used, errors, and things like that. And you can see all the different tabs all in one place, how your agent is doing. And we'll come back to this in a second. Let me see if I can do anything. Ignore the permission denial location. I'm using a different user this time for this demo. So for the voting agent here, you can see that we're collecting memories through the every time I hit thumbs up and thumbs down. So if I click on the voting agent here, you can see these being collected over time, whether I disagreed or what I prefer. And that's getting fed into the agent. And when the judge makes a decision, it's using the APIs to pull from that. Next thing I want to show is the sessions. This is where you can get a view of how your agent is performing. You can see all the different user sessions of the agent. I can open this up and we can see what actually happens. So remember, we had the full transcript. I put in my requirement. We kind of went back and forth. I provided the feedback. So you're seeing that in the view. You're also seeing logs if you want to see if there's anything going on. Again, in a agentic world, we don't necessarily want to be hovering over the logs and looking at those, but rather setting up triggers, having other agents looking out and fixing things. But certainly this information is all there. Maybe time for one more thing I'll show, which is the agent registry. And this is where you can take your agent and share it with other teams within your organization. And so you can see my voting agent is listed here. I haven't done all the needful things to get it set up with A to A. It wouldn't take long, but yeah, it's shown here. And it's using the agent engine. That's where I deployed it. And yeah, it just basically allows you to add it to this central catalog so that other folks can use it. Also, MCP servers, you're seeing if there's tools, not just the agents themselves, you can make those available. And you'll notice that there's a whole bunch of different MCP servers for the Google services so that you don't have to be an expert in each of these products. Your agent can call out to a database or various services available here through product level MCP servers as well. And finally, one last thing I'll just point out here is evaluation metrics. So for your agent, you'll want to define an evaluation scheme. You can use some of the out-of-the-box ones here that don't require an eval set, where you can just look at the responses and it can talk about the response quality. And in other cases, you can give it some expected responses, and then it'll create metrics out of that. Well, I think, let's see, that is it for today. I think we have a few minutes for questions, if anybody's got any.
Hey, thank you, Karl. Thank you for the informative walkthrough and very practical demos. And everyone, if you find out any opportunities that you may need some kind of detailed information or like even Google Cloud products, I believe Karl would be more than happy to help you with that. So feel free to reach out. Now I've seen some questions in the chat box. Tianfei, are you still here? Do you want to ask your question?
Yes, I'm here. Yeah, I do have a question because I'm a recently graduate and working as a software developer at a startup, and I'm building AI apps, which is a fitness app based on Gemini. And here's a situation I made, which is I don't have much development experience, but I really uh, use like Cloud Code do my whole work, and I believe I'm doing it very fast and good enough. But my manager said, "Hey, you should be able to read your code because most of the time I just let Cloud Code do it and check it and make a PR, and I do not even know what he's doing." So here's my question because I'm not sure I should spend a lot of time to learn how to truly read and understand code, or it is better to focus more on the AI agent architecture or new AI technologies instead. Which one do you think is better for me?
Yeah, I love this question because that's something that I think a lot of people are in your shoes and asking the same thing. We have a lot of new folks to technology, or that are like yourself, that are recent graduates, that have to kind of decide, do I want to look at things from an agent perspective, or do I kind of look at from the traditional way. Also, we have a lot of folks in different roles, like product managers or other roles that are starting to build things themselves, and we kind of look at the roles expanding. That traditional job roles have been more narrow. With AI technology, you can do more things. So back to your question, I think it's okay to keep focusing on the AI agent architecture and the AI technologies. I would work on, in parallel, trying to understand the code as much as you can. And I would say, um, asking the agent for help. Like when you're confused, or use it as an educator. Say, "Oh, can you tell me how that worked? Why did you make that decision?" So there's an interesting blog post by Anthropic. You can look it up. I don't recall the where it is exactly, but it kind of talked about education in the era of AI, and some of the traps of, if you just ask the agent for help, are you skipping some of the learning? And so my take is, you don't need to be a coding expert. We're going to work at a higher level in the future, but when it comes to tricky parts of the code, like, it's certain, testing best practices, subtle bugs, it certainly doesn't hurt to be able to dive in, but AI first is completely fine.
Okay, thank you for your answer. And I have another question. Maybe by your forecast, maybe 2 or 3 years later, is that possible? No one need to read code anymore, and everyone will, just ask AI and let AI do the development things. Do you think is that the future, or maybe we still need to read code?
3 years is a really long time, the way things that are evolving right now. And I could see a world where in 2 or 3 years from now, for many problems, uh, you don't even need to look at the code. That you're, working with the specs, you're working with your intent. Here's what I want done. Here's, how to do it, and maybe not even how to do it, and that's it. Um, Again, I think we're still at the point where the models and the agents and the technologies that need some handholding. It's not quite there where, for enterprise problems, if you think about, you ask yourself, okay, if this is, you know, banking transactions, if this is healthcare, am I really ready to just do that? Well, we're not there yet, but we are, and that's where agents and humans are working together. But we'll see. I mean, I think that with the pace of technology, I think we're getting we're getting pretty close. So.
Mm-hmm. So in that case, if I gain some experience, if I try to interview some big companies, what kind of skills or strengths should I showcase, and what can I do to land a better position?
Yeah, it's interesting that there's some debate too with interviews in our new world around, should we have coding interviews that allow the use of agents? I tend to believe that the reality is that's how people develop, and that you should give people the tools and not necessarily have to memorize the coding algorithms off the top of your head. So I think it's about these days a clear thought process, using the tools, knowing um, the how to apply them. Like you need to build this enterprise application with AI. Where would you start? How would you build it out? And kind of explaining how you'd, the concepts we talked about today with skills and MCP servers, and be able to explain the notion of context windows. And, I think a lot of this comes from doing, but just, being able to show that you would be efficient with using the tools.
Okay, got
Yeah,
that.
and
Thank you,
regarding
Karl.
that, I think another key point is transparency and honesty,
Yes.
right? If you use that, you better declare that at the beginning. You cannot use that for cheating, for sure.
100%. Yeah. Thank you.
Yeah, that's all my question. Thank you so much.
Of
Yeah.
course.
Next, thank you for your question. Next, Sylvia.
Hey, thank you so much for the session. This is extremely insightful. This is the first time I saw the Google ADK. So thank you for showing that. We are still pretty early at the adopt some agentic AI work. We're starting some prototype type of process to say how can we build agent to build some autonomous system. So this again, this session is really helpful for us to get started with the journey. I think one of the concerns or questions we always have is when you go from a prototype type to more production, right? Especially for some mission critical system. This observability is definitely start become a big concern, and also not concern, I would say a big topic right now. How can we get the telemetry and also the performance data for the agents? I think my question specifically is more around the agent evaluations, right? Because I think right now people have many different model, many different agent design pattern can start helping with the hallucination. But I guess for more mission critical process, for example, I would always accept the agent would follow those 100 of playbook, right? When running into those scenarios. Do you have any suggestions or insights on what are some good, strong eval for the agent performance for people to gain confidence when moving to those more prototype to more like a production type of system? Thank you.
Sure. So one of the metrics that I think is the most important is the tool calling metrics. So think about it this way. You can ask an agent an answer to a question. If you said, okay, well, what's, here's the DFW group. What's the population of the DFW metro area, right? It might have memorized that answer, and give you the right answer. And then if you don't think about tool calling, you'd say, oh, it's doing a great job. You're only looking at the final result. But instead, you want to make sure, is that agent actually calling the database that looks up the result? And this is where, when you're doing your evals, you can give it the required tools that you would expect it to call during a trajectory of asking different questions. And when it's consistently doing that, then you're going to feel really confident about it. That would be the number one thing. Also, doing more static analysis, of course, the traditional way of give it realistic user-facing questions and expected responses, and then make sure that those line up. And then maybe one last thing would be, with your leadership team, and with the, sometimes people can be anxious about AI and the results, but think about it this way: is like traditional software systems have bugs too, and the question is really, what's your baseline? What are you measuring today in your business process? How good is it? Now, with your AI project, you try to exceed that, and then you show the difference and improvement over that. No system is perfect, but you need a baseline to show the improvement.
Yeah, that makes sense. Thank you so much for the insights.
Sure thing.
Thank you for your question, Sylvia. YJ, but after YJ, we may have time to take one more question. So, YJ, do you want to speak up?
Hi, Karl. Thank you for the very good insight for today. And I'm a project manager, and I'm working a traditional development life cycle. It's good to see the evolving, the impact by AI. But I would like to see if you could have some suggestion as the traditional project, life cycle project manager, and what should we kind of prepare ourselves to adapt to this new life cycle, new way of working, and how can I, support the process?
Sure. Well, I'll tell you, for me, one thing that has helped a lot with is project documentation. So say you're kicking off a project, and there's a lot of things like you should do in the project management, like PMI life cycle, you need a communications plan and list of stakeholders and things like that. And I think it can really help to help you with those initial planning documents. And also I use it to test what I'm doing. Say, here's my plan. Do you see any holes in it? And try to make it better. So using AI as your partner in what you're already doing. And then I think also when it comes to some of the automation, like things like project status, this is where you can start to vibe code, like, well, I need a system that pulls statuses from Jira and updates this system, and things that would be like, oh, well, we don't have time and resources to implement that. Well, now you can, put together those things quickly. Also, dashboards are easier than ever before. Like, hey, I've got this data or reports that are a little bit hard to show to our leadership. Put together some, charts and dashboards and things, and it's quicker than ever before. So whether you're coding or not, I think just thinking with that AI mindset, how does it speed up what you're doing? You could totally do that.
Okay, thank you. Thank you, Karl.
Sure thing.
Okay, just saw the last question for Zhao Yan.
Yes, thank you so much for the sharing. My question is, so how can we effectively develop agent system mindset? Because I just started to learn agent and try to build some in my daily work. What I feel is like maybe the uniqueness or what help differentiate a good agent versus a bad agent is not more about how fancy the technique is, but it's more about how you design the architecture or the system itself. And I'm not sure whether you have any suggestion for a new agent learner how to quickly to form that type of system mindset or system sense, how to build a good agent. Like, for example, should we use auto GPT style or React or just long graph, or how many sub agents should we design, and how to set up the fallback or guardrail? Like, I guess there are trial and fail and learning during the process, but how to make this process more quickly, and how do we develop that sense?
Yeah, that's another question I think everybody's grappling with. I think number one is just doing the learning and your homework on the constructs, the agent, tool, MCP server, A to A, less about the framework itself and more about what each of the pieces of an agentic software is supposed to do. And then a lot of it, like you said, is, a bit of building and practice around, kind of seeing, oh, okay, this architecture was over-engineered, or this is about the right size. I think it's always like there's a middle ground of like, you don't want an agent that does everything, but you also have another problem if you split it up too much. Then it's like with microservices, this idea of every little API is something, and then you end up with companies, all this huge catalog of things that are tough to manage. So it's kind of one of those art and a science type of things, but just keep building, keep reading a lot. This stuff is changing so quick. So whatever advice I give you now, in a month, there's going to be a better way to do it. So just, be learning at all times.
Got it. And I'm sorry, I have a follow-up question. So because everything is changing so fast, and just now you also mentioned after 3 years, maybe no one need to code. So what is the how do we differentiate ourselves after 3 years? What is the uniqueness that enable us to like stand out? Is it like the business sense or how to identify the problem to solve?
Yeah, that's what I was going to say, that, coding is just the tool. It's how it gets done. It's the idea that you own. And that's unique. Like you're trying to solve a problem, you can just now be faster at it. It's no different from, hey, before there were calculators versus after there are calculators. You wouldn't waste your time doing it by hand. So this just helps you move quicker. But the way I look at it with AI is that it is looking at existing human knowledge and bringing that all together at your fingertips, connecting the dots across things. But it doesn't come up with unique, novel, creative innovations that have never been seen before. So that's where you come in and you kind of connect the dots and steer the AI in new ways.
Got it. Thank you so much.
Sure.
Cool. Thank you. Thank you, Carl and everyone. I really hate to say this, but time really flies. All right. I believe you must have a lot of other questions as well, which we don't have time to discuss at this session. But join our circle. We can keep communicating. And given this AI and whole thing is so new and developing so fast, right? In fact, I don't think anyone can have a correct answer for every question. And no offensive, Carl, but I believe you will agree with that. So let's keep communicating, right? I think the only way to find out the right answer for your question is through practice and keep learning. All right. So join our competition, practice your skills. Yeah, that's all for today. Thank you, everyone. Have a good rest of your weekend.
All
Thank you,
right.
everyone.
Have a good weekend. And that was a great talk.
Thank
Appreciate
you.
it.
Bye.
Thank you,
Bye.
Karl.
Thank you.
Thanks.
I see a lot of applauses.